Okay, 6.2, simple and compound interest. What's your question?
I have a theory.
No. Okay. Okay, so let's start it off. So, simple interest is not used in daily life unless you have like an agreement with a friend or something like this. So, we're going to just quickly go over simple interest. But for the most part, everything is done using compound interest. So simple interest is based on a few things. It's based on principal. That's terrible. It's based on principal and term. So principal, not like the principal of a school. It's the principal of money. Yep, so it's your starting amount. Okay, so you might want to just highlight that. The principal is the starting amount. Zeke. And the term is the length of time. Okay? So principal, I would just jot this in. That's your initial amount of money. And term, this is going to be time in years. We're always going to use years, okay? Now, if say you had a loan for like 3 months, you would have to do 3 divided by 12 to get that into years. Okay, we'll talk about that shortly. And it's also based on a rate. So right here, highlight the word percentage, and that is called your rate. So if somebody charges you 20% interest or someone charges you 5% interest, that's called the rate. So there's 3 things that interest is based on, and that's simple interest, okay? Interest is based on principal times rate times time. The R stands for rate, but it is going to be a decimal. So if it was 20%, you would go to 0.20. And time is in years. So example, if it was 3 months, you would go 3 divided by 12. Okay. You need to test, yeah. Thanks. Okay. And everything that I just said is laid out right there as well. This last formula, A equals P plus I. So what did we solve for in the above formula? We solved for I. Once you get that value, you have to add it back on to the original amount. So P is the original plus I, which is the interest earned. So basically, you say you had 20 bucks and then you earned $5 interest. This is 20 plus 5. How much do you have in the end? 25, right? Do you want me to say that again? Here's principal. Say you put in 20 bucks into an investment and you earned $5 in interest. 20 plus 5, what would you end up? 25. So A will stand for like the final value. I'm not sure why it's A. Maybe it's amount. I sometimes say like the accrued amount. That's a big word though, so it's just the final amount. Alright, let's take a look at some of these examples. Build your skills 1. And you can see the PRT all laid out for you, so all you have to do is times these things, okay? So that's what we're doing here. So I'll just put it up above. I equals P times R times T. That's what we're going to do for all of them. So 1,000 times, what's the decimal for 2.5? 0.025 times 1 year. If people are needing a review of percents to decimals, it's just a factor of 100, okay? To go from percent to decimal, you divide 100. And to go from the decimal to percent, you times 100. Okay, just in case you forget how to work with percents and decimals. Late slip.
I was already in class.
When?
Yeah.
You're like a ghost. I didn't see you. Spy or something. So this investment would earn 25 bucks. So if the interest is 25 bucks, what's the A value, the final amount? 1,000 plus 25, which is 1,025. Okay. So you can go ahead and work ahead of me, and just double check as you're going along. So all these are very similar. You'll notice that they got 50 for 3 of them, and the one is the one that we started with is half of that 25. So if you stare at this long enough, you probably start to see some patterns. Like, why is this one 25 and this one's 50? 50 compared to 25 is how much? Double. And what happened to the interest rate? The interest rate doubled. And that's why it's called simple interest. Everything is just a factor. Okay? And then you'll notice if you compare the A to C, 25 to 50, what did they change? Just the year doubled, so 25 doubles. And then for the last one, A to D, what did they change? A to D. They doubled the principal, so you double the interest earned. So this is why it's called simple interest. I think credit cards might use simple interest in their calculations. The book that we're working in, they believe that credit cards use simple interest, and that's what we're going to use to do our questions for credit cards and stuff. But I think in real life, I think credit cards actually use compound interest. So the book might be a bit wrong, but it is what it is. And E and F is what we just talked about. So what happens to the amount of interest when the principal and the term stay the same but the rate doubles? Interest doubles. Principal and the rate stay the same but the term doubles? Interest doubles. Then it says, alright, calculate the value of an investment of... So this is a type of question that will be multiple choice style. So I would recommend you write down P times R times T. Marlon? Austin? Paying attention? Writing stuff down? You're doing both? Okay. Okay, so what's the principle here? Just yell it out. 600. What's the rate? So what do we do with the rate there, Birch? Put it into decimals so you get 0.0375. Yeah, it's 2 decimal moves, guys. And then the last one is the time. And it says 5 years. So 600. So 112 bucks. How many of your calculators say 112.5? Do you write it like that, or do you put a 0 on the end? Put the 0 because it's money. Put the dollar sign. Okay, how much money would you have after 10 years if you deposited $1,000 at a rate of 4.5% simple interest per annum? We could do this one probably pretty quickly. 1,000 times 0.045 times 10. You guys are pretty quick on those percent to decimals, just 2 decimal moves, right? Hopefully by now, this time in your life, you should be able to do that. So 450 bucks. And like, think about this for a second, just in real life application. You're gonna put $1,000 for 10 years to get 450? Is that worth it? No. Simple interest is not really a real thing. The real application in actual life is this thing called compound interest. There's a Drake song you guys might know. He keeps repeating himself. Maybe if I say this, you might be able to know what I'm saying. So, compound interest, you say it's interest on interest on interest on interest. What does Drake say? Something similar to that? It didn't work. Okay, anyways. Compound interest is interest on interest. Okay? So, with simple interest, the only percentage you get is on that original amount. So what happens with compound interest is you earn some interest, it goes back to the original, gets added on, and then you get percentage put on that new amount. So it starts to grow much faster than simple. Okay, so let's take a look. Compound interest is interest calculated on the principal plus interest earned in prior compounding periods. Okay. So this is like interest on interest on interest. So this is the good stuff. So for example, if you invest money for 2 years but earn interest annually, do you guys know what that word is? What is annual? Year. Yearly or annually is yearly. Okay, so if you invest money for 2 years but earn interest annually, the second year of interest will be calculated on the value of the investment after 1 year. That is on the principal plus the interest. You will earn even more interest than if it was simple. Okay. Any questions on that? Okay. Yeah. Half of them aren't even here. We're teaching it every day. Alright, so compound interest has these things called compounding periods, okay? Now compounding periods are going to be different every question. Sometimes it's going to say your investment is compounded annually, or sometimes it's semi-annually, or sometimes it's quarterly, or sometimes it's monthly. And in terms of credit cards, they would even say it's compounded daily. Okay? So as the number of compounding periods goes up, so if compounding periods go up, so does the interest. So for example, if it's an investment, it's your money, monthly is better than annually. Because you get interest dumped into your account every month, rather than every year. So then you get interest on more money, on more money, on more money. Okay? However, if it's a debt, like a credit card, and you owe money, this would be worse for you. Because your loan, the interest is rising and rising, and it's not working out in your favor. So the more compounding periods means the more interest that will accrue. Okay, so they have listed on this book, they got semi-annual, which is twice a year, every 6 months. Quarterly, which is 12 months divided by 4 quarterly, so that's every 3 months. So like March, June, what's the 9th month? September, and then December. So 4 times a year you'd get paid. And then monthly, that's every month, so Jan, Feb, March, etc. And then daily, 365. And that's, in real life, this is what I'm pretty sure credit cards go after, 365 daily interest. That's why it's so scary to rack up credit card debt. Here's the formula. She's nasty. She's actually beautiful in terms of like the math nerd. The true math nerd loves this formula. Like, it's used in calculus. It's pretty powerful stuff. But for us, with applications just to real life and just talk about money, like a banker or an investment banker, like if you went in as a customer, they would just have a program and they would type in numbers and it would spit it out for you. But you could, if you know this formula, you could go into your meetings with the bank or like for example, a car dealership. You could go in there understanding what the loan is going to look like, and you'll know what to take or not to take. Okay, because people, like especially salesmen, they can dupe you, like they can trick you with what they say. They show you all these nice things, beautiful car, and then they go, here's the fine print, and if you don't read it, you can take on a bad loan. Anyways, do we remember what A stands for? What was A in the simple interest formula? Well, wasn't it the final? Yeah, A is the final amount after it's all said and done. Okay, so A is just going to get calculated every time. Very rarely will I ever give you the A value. So typically what I'll do is I'll give you the starting amount, which is the principal. So if you got $1,000 and you want to put it into an investment, that's where it would go in the formula. And you absolutely have to use one of my calculators for this test. Okay, if your calculator doesn't do brackets, like if it doesn't show you everything you're typing in, if you have to type in things one thing at a time, this unit will be brutal. Absolutely brutal. Those calculators include this one here, and this one here. These ones don't allow you to type things in. If you can show you what it's typing in, then it's good. So you might just have to borrow. This one I think is. This one's good. You guys don't even have calculators or what?
Mine's at home.
You're on the right page, man. Well, maybe you are. Where's your book? Why isn't it open? Where's your calculator? That calculator's no good. Are you awake, Stoby? Come on, man. It's perfect. Keela, yours is good. Yours is good. Yours is good. Do you have one? You borrow. Okay. Okay, R. R is the rate, and it's expressed as a decimal. Sorry, I think I had to sneeze there. Okay. R is the annual interest rate, and it's expressed as a decimal. I need you to highlight annual interest rate and decimal. So for example, say you got a 10% interest, which is very high, but they said it was compounded semi-annually, so twice a year. That 10% that you get for that year would have to be divided by the periods. So you'd get 5% on the first period and 5% on the second period. That's why right up in this formula right here, you can see that R is being divided. R gets divided by N, which is the number of compounding periods per year. Okay? And then you have to raise it to a power. This is a power up here. This is exponents. And you can see that when you have something that's raised to a power, it's going to grow much faster than if it's just simple timesing. And T will be the time, of course, in years. So for example, if T was 2 years, say T is 2. Whoops. T is 2. And N is 12. Let's say N is 12. That would represent monthly. So how many times would you get paid in 2 years? You would have to go N times T. That's what that formula says in the exponent. What's N times T? 24. You would get paid 24 times. And if it's in the power, like try to do a small number to the power 24 in your calculator. Is massive. Okay? So exponents will make the investment grow faster. All right, let's take a look at the first question. All right. Number 4, calculate the final value. So what are we looking for? A, P, I, N, what is it? Final value is A. So that's what we want. Then it says the deposit of money is $5,000. So what letter goes with 5,000? P. So put a 5,000. Sure? Better not. Alright, let me just jot down the formula above so you know what's happening. I'll put it right here. Why are you late, man? Huh? 112? Don't lie to me. Okay, so the 5,000 is right here. That's the P. and then you have 1 plus. Okay, so P in the formula is 5,000. 1 plus with a bracket, that's always going to be there. And Rn is going to be the rate divided by the number of compounded periods. So at this point, it's probably a good idea to jot down what those things are. What is R? R is the rate. So 3% is 0.03. Now, N is the number of compounding periods. So to do N, you have to look at the English language on the question where it says compounded. That's the only place it'll tell you. So compounded annually, that is once per year. Semi-annual would be twice, quarterly, 4, monthly, 12, and daily, 3, 6, 5. So we go 0.03 divided by 1. Now we have to raise to power. So at this point you're just writing on your paper. I'll show you the calculator in a second. Now N times T in the power. So that would be, what is T? The time in years. So 2. So 1 times 2 in the power. Once you write it down, that's good for me because I'm marking it, right? To actually calculate the number, you just go to your calculator, okay? Okay, here comes the calculator. So 5,000 was the principal, right? You just type in 5,000. Now what comes next? Left bracket. Now if you don't have this feature, you're going to have to just watch. 1 plus 0.03 divided by 1, end bracket. Now what do you need? The power. So now you go to the power. And calculators are a little bit tricky. You're going to need a bracket on the power. I think it was 1 times 2. So I'll leave that up for a second while you stare at that. Question? It might be like the YX button. Yours will prompt you, so you don't even need the up. Power is that little up arrow thing. Good. Ken, come over here and show these two ladies because they have the same calculator as you. He'll show you how to use it. It's like that? Okay. Yeah, come show Brianna. What was the number? 5. Just say the digits for me. 5, 3, 50. Oh, you typed in 500 instead of 5,000. Okay, now stare at this number and compare it to the original amount. What happened? What happened from 5304 from 5,000? What happened? Yeah, you gained $304.50. So for this formula, to figure out the interest earned, you have to go A take away P. So 5304.50, take away the principal, and you earned 304.50. That's to see how much interest you earned. Excuse me. You guys cool on this? How many of you don't have a calculator right now? You need to come get one from me so you can practice this. Okay. It's okay, Fred. Sonia Brown, Anthony Brown.
I can't find my ID right now, but
It's okay. Today it's all good.
okay.
All right.
Just as important to me, I'm
Grabbing one for me too.
Okay, so for these next ones, when I'm writing it on the board, you absolutely copy it down, and then we do the calculator together. This is a nightmare if you do not follow me with the calculator. Okay? Do you need to put brackets on your power, or did it work out? Yeah, you could. That's a nice one, yeah. Okay, so let's take a look at the first one. I'll do this front in black. $4,000. And then it's 1 plus. Now we have to adjust. Remember, you always adjust the interest rate to decimal. That goes in a numerator here. And then we have to divide by the number of compounded periods, which is 1. And then we raise to the power. It's 3 years. So n times t is 1 times 3. Like, I know it's just 3, but we're just going to be, so you see what's happening. So when later, I know, some of you are just putting 3. In fact, you don't even have to divide by 1 because you're going to get the same result. But I'm just putting it there so you get the structure. Okay, now we'll do the one underneath. 4,000. Oh, this one's simple interest. So let me undo that. Simple interest, remember, is just the principal times the rate. So 0.035 times the years. All right, so I'll give you a second to copy that down. Are you guys okay on that? Okay. So what was the number? 4 grand? Whoops. And then 1 plus 0.035. Oh, I forgot to divide by 1. Power. After the power, I open another bracket for the multiplication in the power, which was 1 times. What What is happening? My computer's having a mental breakdown here. There we go. What was the number in the power? 1 times 3. Okay, so how much money did this guy make? People that are boring calculators, do you know where the power button is? YX. It's on the top right. Both of you at the same time? I'm going to be done in like 2 minutes and then you go. Zaki? Good? So this 4434.87. Guys, take a look. Look at this 1.5. Does that 1.5 matter? Those get just rounded off. You guys ever see the movie Office Space? Nobody? It's an older movie. They create a scam in the bank software where they all these like hundredths of like these are thousandths of pennies. They get rounded off, so they were piling them up in a bank account, and they got rich, and then the place burned down at the end. I don't know if you guys have seen that movie. They got lucky. All right, the wind just shut that door. Okay, so 4434 point, what was it? 87? And the 1.5 got rounded off. So take a look at these numbers. This is crucial, okay? This is crucial for understanding. You went from 4,000 to 4,434. Excuse me. How much money did this guy make? Yeah, $434.87. Now let's take a look at the simple interest calculation, which is the same length of time, the same rate of interest, and the same amount of money. So the answer is 420. Now when you compare the interest earned, remember, you need to take a look at the final amount and subtract the initial amount, okay? So this one, you earned $434.87 because it's been an upgrade of, you upgraded from 4000 to 4434. So that's the interest earned. And this, my formula is incorrect. Can you guys make a change here so you don't get confused? That A on the left needs to be an I because the simple interest formula calculates the I, whereas the compound interest formula does not. So compare 434 to 420. You would rather have 434 if it's your investment. If it's a loan, you wouldn't want that. Okay. So can you guys please try number 6? And if you have to go to the washroom now, you go. Okay, so I'll put up the answers for number 6 here. And I got it all color coded there so you can see where it is in the formula, where it is in the question. Bring it to me, I'll show you.
Exactly what you said. I got 41,000 now. then I got syntax error when I tried it a different way.
So syntax error is when you've typed something improperly in here in the wrong order. $8,000
Yeah.
bracket 1 plus
Yeah.
0.025 dividing 1.
I did 0.025.
That's okay. Power bracket 1 times 5 bracket.
Okay. I didn't do the.
Okay, so let's take a look at the decimal. Now, if you look at the screen, you guys, how much of that decimal do I take? 2 decimals. Marlon, are you paying attention to me too right now? Just for 1 second. You need 2 decimals for money. So if you look at the third decimal, this should be 27. But if you look at the very first thing the question says, what does it say? How much interest was earned, not the final amount. So you need to subtract off what you started with. And you end up with, yes, 1051.27. This is the interest earned. Okay, there's the whole entire question. Okay, so that's it for what I'm going to teach today, and then I'll give you a couple practice questions and we'll revisit this tomorrow.